But when you see the whole thing put together, it's even more so amazing. I can't wait to see this baby launch today.
Yeah, and what's so inspiring, I think, about this, we have a lot of scientists, engineers, and future explorers who are watching this live stream right now. And, just a word to them, what you're seeing on the screen right now it's not taught in schools. You're not going to find a textbook that shows you how to do this. This right here, integrated plane, rocket, and satellites, all as a single system, that was born through ingenuity, creativity, and the imagination of a world-class team, I think one of the best in the world.
Okay, hey, welcome to the stream. My name is Hayek from Planetary Space. Planetary Space is a very good company. You should definitely be. You should definitely fill up the application. It's promoted. I'll send it again. It's gonna be down in the link below. You should definitely sign up to work for the company. It's amazing. We're planning to build so cool rockets. But this live stream is not about my company. It's about Virgin Orbit. So what is happening with them? Well, they're about to have their Above the Clouds launch in 1 hour. Okay, yeah, I will be nominal. I'm not nominal. I'm not nominal. Yeah, I'm not nominal. I was watching this fake tweet. I'm not nominal. I'm definitely not nominal. I was really dumb and I just got quarantined and I went at the shop. Jesus Christ. What? Alright, I'm back. I'm back. So, I'm just going to, let you guys listen to some music. Every day, come to God, every day astronaut.
Absolutely.
So let's talk about the future of Virgin Orbit, actually. I know we have a number of launches coming up. Which one are you most excited about?
Um, I mean, I think that I was just looking at the 747 and having a little bit of a trip down memory lane. And this plane was, I think, the second plane into Virgin Atlantic's fleet, something like 37, 38 years ago. Um, I wasn't sure that Virgin Atlantic would survive more than a year or two, and I don't think anybody were in those days. We were taking on, British Airways with 300 planes, and we had a couple of planes. Um, I certainly was was not sure that, or never dreamt that one day it would be taking off from Mojave with a giant rocket on its side, and putting satellites up into different places in space. And the tremendous thing about using a 747 is we can put them into any orbit from anywhere in the world. Um, so yeah, so it's definitely a pinch me moment. I mean, this goes right back to when I one day saw one of our 747s taking off with three engines on one side and two engines on the other, and we just suddenly thought, well, if you can get three engines on one side of a 747, maybe we could put a rocket on it. The reason for three engines on one side and two engines on the other was, if there's a technical problem in Alaska, you have to send one of your other 747s to bring a spare engine. The only way you're going to get it there is to put it on the wing. As to the future, I mean, I'm obviously excited about every single rocket launch and all the different things that all the satellites inside those rockets can do. I mean, there are so many urgent things that need doing back here on Earth. Whether it's monitoring the rainforests, maybe places like Norway who are doing deals with places like Brazil to ask them to not to cut down the rainforests, and then rewarding countries for not cutting down rainforests. The only way you can properly check on it is really via satellite. I mean, you can do a certain amount on the ground, but to completely verify it on a month-by-month basis, you need to do it from the air. So it's projects like that. I mean, in the Virgin Islands, right here, we have illegal, fishing boats coming through. Again, it needs satellites to be able to alert the authorities that trawlers are coming through with massive nets and long lines and pillaging the seas that belong to the British Virgin Islanders. And that's the kind of role that Virgin Orbit can play. And Virgin Orbit is unique in the world. I mean, the fact that we can actually, there's only, I think, a couple of handfuls of countries that have the capability of sending satellites to space from their own countries. And now all 180 countries can use Virgin Orbit. They just need to ring us up. We can send a 747 and operate out of their own country and launch satellites for the first time. The UK is one good example. I mean, later this year we should be launching from Cornwall. The UK's never put up its own satellites. Now, I think this year there will be two flights from the UK, putting satellites up from the UK, and there are many other countries that have expressed similar interests.
And one last question for you, Richard. So as you may know, we have many international viewers watching from around the globe, but in particular, we have a small number here in California, namely our Virgin Orbit employees, that are primarily watching from home with their families due to the coronavirus pandemic. Is there anything in particular that you'd like to say to them?
Well, first of all, to say, yeah, thank you for all you've achieved. Obviously, we hope for a successful flight, and if it's not successful, we'll be back putting up another rocket. I'm sure, knowing the lot of you within a month or two, but I'm sure it's going to be a success. Um, yeah, to wish everybody well. I mean, our family and friends all got COVID over Christmas, and fortunately we were vaccinated and boosted, and therefore none of us got it badly. I mean, my wife, who's a bit older than me, hardly knew she'd had it. So if you can get yourself vaccinated, get yourself boosted, get yourself protected, you can then I think ride this particular Omicron variant, and be around to watch many more flights, but basically just say thanks very much. I mean, you've achieved something extraordinary, and I know that you'll have lots more extraordinary things to achieve in the years to come.
Well, thank you very, very much for joining us, Richard, and we hope to see you back shortly.
Thank you very much. Cheers. Good luck in the next hour.
Thank you.
Cheers.
And then once that gets approved by headquarters at Space Force, then we take those and then we execute to those. So once STP gets that list, then we work through a process like I talked about, mission design or space acquisition or spacecraft acquisition. And then we go through that process and then we manifest, and that's how we got into this specific mission.
Excellent. So Cosmic Girl just took off. She and Launcher One are on their way to the drop point. It's going to get very exciting here soon. You know, in your
technology, not only that works, but also in a timely manner. And the concept that Vox has, where they're deploying from an aircraft, allowing that flexibility, because now you're not specifically attached to a specific ground point and the challenges that can come with that. So I think we're excited about seeing where this technology goes and the opportunity of that. This is our second launch with Vox. We did VP Alpha, and that went very well. We're looking forward to another successful mission, another opportunity to actually showcase not only the technologies that we have on board this specific capability or the specific mission, but also to showcase the ability of Vox to do their mission.
Well, thank you so much, Colonel, for coming on the program here today. That is Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, demonstrating emerging technologies in space to accelerate the development of space capabilities for the warfighter. Stay tuned for more exciting content. We're getting closer and closer to Launcher One's drop time. Stick with us. We'll be back soon.
LD's Radiohead. I can report we have good signal, good tracking on all 3 ground stations right now.
Copy, good signal, good tracking. I like it.
Home base, Cosmic Girl. We're level 30,000 feet. We remain in cloud.
Good copy, it's 30,000 feet, still in clouds.
Cosmic Girl, orbit base.
Cosmic Girl, go ahead. Yeah, Cosmic Girl Orbit Base. On the S-turn maneuver, what we're really looking for is 30 to 45 degrees of heading change in two different directions. It's your standard INS realignment kind of maneuver.
Orbit Cosmic Girl 01. We haven't been briefed on an S-turn maneuver.
Say that again.
Yeah, this is to address the GNC Converge LCC we're currently not passing. I believe the IMU is not currently aligned, so we're looking to do that maneuver that we're describing.
Okay, that's copied. And can you repeat the maneuver?
Yeah, Cosmic Girl Orbit Base. What we're looking for is two different heading changes, about 30 degrees to 45 degrees each direction. You probably won't be able to do that until you get into the Altrav airspace.
Yeah, that's copied. We'll try and do that as early as we can to get an early call on.
Copy all, thanks.
Above the Clouds is our name for the STP-27VP Bravo mission conducted under the Space Test Program's Rapid Agile Launch Initiative, or RALI. The RALI project was initiated in response to congressional guidance to procure prototype commercial small launch services capable of taking research and development payloads into low Earth orbit. Above the Clouds will launch 4 STP-sponsored payloads to demonstrate flexible, responsive, non-traditional launch capability for the U.S. Department of Defense. Let's take a closer look at these payloads. The Pathfinder for Autonomous Navigation, or PAN experiment, demonstrates a low-cost, adaptable autonomous rendezvous and docking solution using 2 3U CubeSats designed with modular subsystem functionality. Technology Education Satellite 13, or TESS-13, is a 3U CubeSat experiment sponsored by the NASA Ames Research Center, exploring novel capabilities including nanosatellite class machine learning, exobraking for rapid deorbit, and advanced communications. The Global Star Evaluation and Risk Reduction Satellite, or GEARS-3, is a 3U CubeSat sponsored by the Air Force Research Laboratory to explore how a prototype patch placed on the exterior can provide details on spacecraft health via commercial satellite network connectivity. And in addition to these 4 STP-sponsored payloads, the Above the Clouds manifest also includes 3 commercial rideshare satellites. Polish new space company Sat Revolution is flying their Stork 3 and SteamSat 2 satellites. Stork 3 joins the Stork 4 and Stork 5 MARTA satellites placed in orbit by Launcher 1 on our 2021 Tubular Bells Part 1 mission as part of Sat Revolution's Earth observation capabilities, with a focus on customers in the agricultural sector. SteamSat 2 is a technology demonstration for Steamjet Space System UK's innovative water-field thrusters for in-space propulsion. And finally, as a late call-up addition to the Above the Clouds manifest, from final approval to full integration in less than 24 hours, is Spire Global's Adler-1 satellite. This 3U CubeSat mission is the first privately organized satellite of Austria, tackling the challenge of micro-space debris, small particles with high velocities that can pose a serious danger to orbiting satellites. A partnership between the Austrian Space Forum, Findus Venture, and Spire, Adler-1 focuses on detecting nearby objects too small to detect from the ground. This nanosatellite detects space using a piezoacoustic sensor that vibrates on impact, literally a microphone in space. Findus Venture is financing the mission, and the Austrian Space Forum is a space research organization with more than 250 volunteers from 20 countries. To these 7 payload teams, welcome aboard Launcher 1. And we wish you 100% mission success as you go above the clouds to use your technologies for the benefit of all of us back here on Earth. Now, let's hear more about the TESS-13 satellite in particular and the amazing team behind this satellite. Go ahead and roll the video.
This is TechSat number 13, and this is our second flight on Virgin orbit, which we're very happy to be part of. And this particular mission is a 3U nanosatellite, and it's full of rather interesting and innovative experiments. We're very cognizant of orbital debris, and so by having a drag device that is simple and reliable, it means that we can bring our nanosatellites down and dispose of them a lot faster, not having them as a potential debris for other satellites or human vehicles to run into.
And I'm really happy to be part of the ExoBreak team. So I was involved in the design and the building phase of the subsystem. So we are a small team, and I really want to acknowledge one of our colleagues, and I call him like the hero of TechSat. He's really quiet, really discreet. His name is Alejandro Salas, and he's our lead ops engineer.
This will be the first of a series of flights that will begin to expand on machine learning in space.
Today we got a chance to go in the clean room, do the final voltage testing, and then with the help of the Virgin Orbit team, we were able to integrate the satellite into the flight dispenser. Today was a really smooth process that my team and I hope Virgin Orbit team also enjoyed.
We command and control satellites through email, which is very unique, and we pioneered that some years ago, and it works to a great extent. We got injected into a perfect orbit, and that was a year ago, and then 9 months later the satellite still sends lots of valuable data, so it's up there. The timing will be such that we'll have 2 satellites in orbit at the same time, thanks to Virgin Orbit.
I think TechSat it's really important from the NASA standpoint, but also for the entire space community. TechSat group gives an opportunity to entry-level engineer to really be part of a space mission, and I think you change the entire space ecosystem because you get a chance to fly your own payload. When I was doing my master's degree at San Jose State University, I was already part of the TechSat team, and that's where I started working on the ExoBreak. So over the past years, I was able to work on 3 ExoBreaks. To be the first female customer, first of all, I was surprised because I was greeted here by 3 or 4 women, right, at Virgin Orbit. So I felt like home. They were all the personnel here. It's really, really nice, and they make sure we have everything to complete the integration.
We're just happy to be here again, and we look forward to 2 more flights in the next calendar year.
Thank you. Thank you to my team. Thank you to Virgin Orbit, because I also think that it's a great collaborative effort. And during this challenging year, we were able to work together, put a satellite together, and today integrate. So we are all, cheering for Virgin Orbit right now and hoping for the best.
So for those watching a live stream today, what you've most likely seen in the background is a number of graphical user interfaces, or GUIs. Now these GUIs are composed of some of the parameters our launch team across Virgin Orbit are monitoring to make sure they keep track of the health and status of both Cosmic Girl and the rocket. Let's go ahead and take a look at one of those GUIs. These GUIs will show captive carry, stage 1 extent, and stage 2 extent. The current GUI that we have on the screen right now is for captive carry. To give you a little breakdown of what you're seeing on this GUI, let's first focus on the primary section of this one. Here you see animation or a comic version of the rocket itself with a couple of our tanks overlaid on top. Those tanks represent our fuel and liquid oxygen tanks. Here you can see the fill level. Obviously, since we're still in captive carry, they haven't decreased yet. Up below the rocket, you can see some of the other components that comprise our rocket, like Newton 3, stage 1, inner stage, stage 2, and the payload. Here, we're tracking some of the key at an altitude of 31,000 feet, as well as our pallet and pylon, which is our separation system for the rocket. So by all means, stay tuned throughout the rest of today's mission and take a look at these GUIs as they update, as they'll provide plenty of information on the relevant section of our flight segment.
Hey guys, I'm back, and I am back, and honestly, well, this is the live stream. Okay, guys, life has to end now. See you later.